Hi guys, and welcome to another video. Today we're going to be looking at statistics, and the sections that we're going to be looking at is measures of central tendency and dispersion. And we're going to be looking at univariate data. Univariate means one variable. Quickly, what is measure of central tendency? Measure of central tendency is basically finding the mean, the median, and the mode. Well, what is the mean? Well, the mean is just basically our average, and our average is x bar. So it'll be the number of values that we have. So what we need to do is add up all the values and divide it by how many values we have. So it's finding the average. Then we need to find the median. Now, this is important. When finding the median, we must remember that for univariate data, there's two types of data. We can get grouped data. So for grouped data, our median Q2 will be the number of values over 2. So that's the position of our median. Now remember that for univariate data and for grouped data, remember for grouped data, it would be already tabulated for us. Now for ungrouped data, we have to arrange our ungrouped data in ascending order. And for ungrouped data, the position of our median will be the number of values plus 1 over 2. So number of values plus 1 over 2 to give us the position of our middle value or our median. So mean, median, and finally the mode is the value that occurs most often. Now for measure of dispersion. Measure of dispersion is basically looking at the spread of our data. And we're going to be looking at two types of measures of dispersion. We're going to be looking at the standard deviation. So for measure of dispersion, we're going to be looking at the standard deviation, which is denoted by the variable sigma. And the standard deviation is the spread around the mean. We're also going to be looking at the measure of dispersion. The second one is the interquartile range. So the interquartile range is going to be the third quartile minus the first quartile, or the upper quartile minus the lower quartile. Okay, and we need to remember the 5-number summary. The 5-number summary is going to be important for drawing of the box and whisker plot. The 5-number summary is your minimum, your maximum, Q1, Q2, and Q3. All right, so that's basically the background information that is required, and I will elaborate on this a little later. Let's look at the first question. I'm going to be looking at this question from the February-March 2018 paper 2. And here it says an organization decided that it would set up blood donor clinics at various colleges. Students would donate blood over a period of 10 days. The number of units of blood donated per day by students of College X is shown in the table below. So we have the days from day 1 to day 10. So therefore, N, the number of days that we have, is equal to 10. And the units of blood will be 45, ranging all the way up to 106. And you can see that this is also arranged in ascending order, which is from smallest to biggest. And that helps us to find our median. Now, let's look at this. The first question is calculate the mean units of blood donated per day over the period of 10 days. So for this, we'll use our calculator. Let's go to stats mode, and we're going to be looking at univariate data. So there's it here. So we're going to put all our values x. Right. Frequency is optional. You can keep it off if you want to. 59 is our second value. 65, 73, 79, 82, 91, 99, 101, and 106. 106. So now once all our values are inputted in our calculator, so now we will press AC, Shift, and Stats. We need that button there. Now we want to go to our mean. Now let's look very carefully. So if we can go directly to the answer, it would be option 4. and X bar is our mean, and press equal to. So X, so the number of units, the average number of units of blood would be 80. So that's our solution. So for 1.1.1, our answer X bar is equal to 80. Now, if we were to show our working here, remember that X bar equals to sum over the number of values. Now, we already know that our answer is equal to 80. So we can write that down. But let's say we wanted to show the working. So we'll go up here, shift and 1 again. We put sum, which is 3. The sum of all the X values, option 2, equals to 800. So this is 800 over n is 10, which gives us 80. So it's up to you. If you were to write the final answer only, you would get full marks. Second question, 1.1.2, the standard deviation of the data. Now remember that the standard deviation is a measure of dispersion, and it's the spread around the mean. Basically is telling us how far apart our values are from the mean. So 1.1.2, the standard deviation. Once again, you can go to our calculator for the answer. Option 4, standard deviation, yes, option 3. That's equal to 18.83. We'll round to 2 decimal places. So that will be 18.83 units. 18.83 units. Okay, now let's look at our next question. In our next question, 1.1.3, how many days is the number of units of blood donated at college X outside 1 standard deviation from the mean? Now, let's read this question one more time. How many days is the number of units of blood donated at college X outside 1 standard deviation from the mean? Now, to answer this particular question, we need to get our interval of 1 standard deviation from our mean. So for 1.1.3, we are going to do the following. So 1 standard deviation will be as follows. So it will be X bar, let's write that down. So the mean minus 1 standard deviation to our mean plus 1 standard deviation. And therefore our interval will equal to 80 minus 1 standard deviation, which is 18.83. And this will be 80 plus 18.83, which will give us the following interval. So let's work it out. So we got 80 minus 18.83 equals to 61.17. So our interval is 61.67, and it's going to go up to, so that's the lower boundary. The upper boundary would be, add it up, 98.83. 98.83. So that's our interval 1 standard deviation of the mean. So now let's count all the values that are outside of 1 standard deviation. So therefore, let's look at the lower boundary, 61.67. So all values lower than that will be outside. So if we have to count here, it will be these 2 values, 45 and 59. Okay, and above 98.83 will be on day 8, day 9, and day 10. So therefore, if we count all the values here, or the number of days, because it says how many days is the number of units of blood donated at college X outside of 1 standard deviation. So that will be 1, 2, 3, 4, 5 days. So the answer is therefore 5 days. And that's our solution. Let's look at the next question. The number of units of blood donated by students of college X is represented in the box and whisker diagram below. Now remember that the box and whisker diagram is a representation of our 5-number summary. So basically it's a graphical representation of your 5-number summary. So that's your minimum, that's your first quartile Q1, that's your median Q2, that's your third quartile or upper quartile Q3, and that's your maximum value. Okay, so even if they asked us to draw this box and whisker plot, we could do it because we have all the information here. Now, let's look at this. What do they say? Describe the skewness of the data. Now, if you want to describe the skewness of this particular data, now what we're going to do is we're just going to compare the mean and we're going to compare the median. So let's compare the mean and the median. So let's work out what the median is. So the median would be, remember that this is ungrouped data, and for ungrouped data, to find the position of our median, it's going to be the number of values plus 1 over 2. So therefore, that'll be 10 plus 1 over 2, which will be 5.5. So therefore, our median lies between the 5th and the 6th value. So therefore, Q2 is going to equal to 79 plus 82 over. So therefore, our median is 80.5 and our mean is 80. So our mean is 80. Remember, 80 is less than our median, which is 80.5. Therefore, our data will be skewed left, or you can write down negatively skewed. Okay, let's look at the next question. Write down the values of A and B, the lower quartile and the upper quartile, respectively, of the data set. So remember now, A and B is the lower quartile and the upper quartile, respectively. So let's look at that. So what we're going to do now is, in order to find the lower quartile and the upper quartile, so let's look at that. So in our lower half of values, so let me just clear this up here. Now it's very important for us to separate our values into the lower and the upper half of values. So remember that our median Q2 is equal to 80.5, and that goes in between the 5th and the 6th value. So the lower half of values here is basically from number 1 to 5, and then the upper half of values now is from 6 to 10. And what's important for us to understand here is that the first quartile, or the lower quartile, is the middle of the lower half of values. So that's going to be my Q1 value. And the upper quartile, or the third quartile, is the middle of the upper half of values. So that's going to be Q. So therefore, A is going to equal to 65. So for 1.2.2, A is going to equal to 65 and B is equal to 99. B is equal to 99. Once again, remember that your median Q2 is the middle of all of your values. So it's in between the 5th and the 6th value. That's why we inserted it here. And the Q1, or the lower quartile, is the middle of the lower half of values. Lower half of values, there's 5 values in the lower half and 5 values in the upper half. So Q1, the lower quartile, is the third value. So that'll be 65. And the upper quartile is 99, which is the 8th value. So it's very handy for you to separate your data after you've arranged them in ascending order into the lower half and upper half of values. Let's answer the last question. If it was discovered that there was an error in counting the number of units of blood donated by College X each day, the correct mean of the data is 95 units of blood. How many units of blood were not counted over the 10 days? So now they're giving us the correct mean. So in 1.3, remember that mean is equal to the sum over the number of values. So what are they asking us here? They say it was discovered that there was an error in counting the number of units of blood donated by College X each day. Correct mean of the data is 95 units of blood. How many units of blood were not counted over the 10 days? So what we're going to do is we're going to let the number of units of blood that wasn't counted be X. So therefore, remember now they gave us the mean, which is 95 is going to equal to, so the original sum that we had was 800 plus x all over 10 for the 10 days. So therefore, if we cross multiply, we get 950 equals to 800 plus x, which will leave us with x equals to 950 minus 800 is 150. So therefore, 150 units were not counted. 150 units were not counted. Learners, if you haven't subscribed already, do subscribe to JL Maths, and I'll catch you in the next video.